All right, good morning, good evening, good afternoon, and welcome. So, voice is still a little down, but we should be able to manage it. This is part 2 of factoring quadratic trinomials. The big thing we're going to be focusing on today, everybody, is making sure you guys understand that when we're going through this process, we are going to be focusing a ton today on values the a value other than 1. Okay, this is a very challenging lesson, not only to teach, but to understand. The only way you're really going to get better with this is to practice, practice, practice. Now, over the years, there have been multiple ways how I've shown how to actually solve this, okay? Today, I'm going to try something new, something that I think will be beneficial and kind of put everything together as we've gone through this process, okay? And what I mean by that is on 8.5, we used the Punnett Square and we did reverse factoring. All right, if you haven't watched that video, go back and watch that. We basically put a Punnett Square down, we put 4 terms in the middle of the boxes, and then we factored out the pieces and we were able to create our equations. Then yesterday, or on the last lesson, 8.6 part 1, we did the X method, where you would do the factoring, okay, where it would be what numbers on top is multiplication, and then the bottom is adding, and then you have the 2 numbers. Today we're going to combine both of those processes together, and we're going to create, and hopefully you guys will understand a better way of factoring. Now, in the book, I just want to let you guys know, it does talk about writing these equations out and using it by grouping. Okay, I don't like teaching this style method because a lot of you don't understand it, but I will show this up to you on the screen to make sure you guys understand. So what they're doing here is what we focused on when we do the X method. Okay, when we pull out the easy X, and we would put on this equation, or you try to figure out what 2 numbers would multiply together. The problem with this is that you guys can see they go from a -13 to a -10 and -3. They're troubleshooting to try to see what the answers are, because nowhere does it actually say to you how to actually get these 2 terms here. How did they get -10 and -3? Well, the main reason they got it is because they actually took this number right here, 5 times 6. So if you guys remember, this is the A, B, and C. They took this value, multiplied it together to make 30, and then they figured out the terms in the middle. It's difficult to kind of look at. If you want to go and get more in depth on how to do something like this, please go to Khan Academy or some other resource and figure it out. But what I'm going to show you hopefully is going to be a 2-step process that's really simple, that's going to be really fast. Okay, first things first, for all these lessons, as we've talked about before, we need to identify what the A, the B, and the C are. Okay, it's very important today that we move forward, especially when we get into quadratics. You guys are going to be tested on this, not only in my class, but next year when you're in 10th grade, when you guys take the AZM2 or the test. A lot of it is on algebra and quadratics. And this is the beginning stages of that, where you guys need to know these values. Okay, so we know this is 3, 11, and 6. A is 7, and then it's 29 and 4. And then it goes 5, 27, and 10. All right, if you guys remember from yesterday, same thing applies here today. Where when we did the X, okay, so we're going to draw a flat X like this, a flat X like this, and same thing here. Remember what we said was, it's A times C on the top, and then it would be B on the bottom, okay? So, and then the question was always asked of you, what 2 numbers, when you multiply them together, make A and C, and when you add them, make B, okay? So now we have a different value for A other than 1, so up here, it's A times C, so it's 3 times 6 is 18. If you don't know how I got 18, back it up, do it again. Remember, it's A times C. Okay, A times C is 18, and then it's 11 down here. A times C is 28, and then it's 29 down here. A times C is 50, and then it's 27 down here. Make sure you guys can do that setup, okay? Now we're going to go through the steps. Right, so what 2 numbers? Same thing as before, right? What 2 numbers, when you multiply them together, make 18, and when you add them, they make 11. Well, that would in this case be 2 and 9. Same thing here. Add them together, it'd be 28 and 1 would be 29, and then that'd be 28. And this one here would be 25 and 2. Remember the order of which it goes on which side doesn't matter? There's our basic setups. Now, ladies and gentlemen, you got to fill in the Punnett Square, and this is how you fill this Punnett Square in. All right, first off, we are going to go with the first term is in this box here, and the last term of the quadratic goes here. All right, same thing. First term of the quadratic goes here, or the trinomial, the last one goes here. First term of the trinomial goes here. The last one goes there. All right, now what you're doing is you're going to fill in your blank. So we had a 2x and a 9x. Okay, don't forget the x because that's what that represents. Same with here, 28x and then a basically just an x. All right, because that would be just a 1x. And this one here would be 25x and then a 2x. And these are all x's, right? Okay, good. All right, now, ladies and gentlemen, we're going to reverse factor out like we did with the Punnett squares. Okay, so when you reverse factor this out, you guys remember, what did he share in common? This would be a 3. They don't share anything in common but an x. Vertically speaking, they share an x and a 3. Once again, if I multiply these two together, I should get this, and I do. And then the last thing would be they share a 2. Ladies and gentlemen, we have done it. Okay, so using these two things, multiplying this and using the reverse Punnett square, we've come up with 3x plus 2, and then it's x plus 3. Now, there are multiple ways of actually factoring and doing this. If you Google search online, you'll see a couple different things called an easy A that deals with a fraction. The only issue I have with that is a lot of you are really bad at fractions, so I think this might be the best way overall for you guys to understand everything. All right, nothing in common, so that'd be a 1. And then rolling across here would be 7x. Okay, remember, you can have nothing in common and just be a 1, but this top one can't also be a 1, like we talked about before. This is an x. Once again, 7x times x would be 7x squared. And then vertically speaking, they share a 4. If you don't know, that'd be a 1, 4, and then double check your work. It works. So my answer here is 7x plus 1, x plus 4. Hopefully you guys see, once you build this up, it comes pretty easy for you guys to do. All right, this is a 2. This would be a 5x and an x vertically, and then that would vertically be a 5. And we are done again. 5x plus 2, x plus 5. Simple. This is actually really complicated to do. But hopefully doing this step and then this step makes this so much easier. I want you guys to make sure and you practice and do this on your own. All right, next setup here, A, B, and C. So make sure you guys have it. If you have not, pause the video, try it on your own, okay? It's very important that you guys try to do this all on your own, especially when it comes, sorry, that's a weird looking 35. Especially when it comes to making sure you guys can succeed on your own. I can't stress enough, the greatest thing you will learn is if you can do this yourself first and fail. I'd rather have you do this in pencil and fail and then redo it than not do it at all and wait for me to give you the answer, because that's not going to help you. If you're scared to do it in front of me at school, fine. Come home and do it. Go home and do it and fail. But try it, and the greatest successes you'll ever have will come from your failures. All right, 3 times this would be 15. And then we have 16 down here. And then 35 and 3 together is 105. And then this bottom number is going to be 26. All right, ladies and gentlemen, now give me the terms, right? What two numbers multiply and then add? This would be 10 and 3. This one here would be 15 and 1. And then this one is a little tricky. And I have a cheat sheet. I've already made it up, so hopefully you guys already have it. It would be 21 and 5, right? Well, 21 times 5 is 105. And you add those together, and that's what you get there. Okay, now we're going to put it in the square. 5x squared goes in here. And then this would be 10x, 3x, and a 6. First term here, 3x squared. Last term is a 5. And then you put these two pieces in, 15x and just an x. And then this one would be 3x squared again and 35. And then it'd be 21x and a 5x. All right, now you factor the pieces out like we did before. Factor this out of 3, 5x, x, and a 2. So my setup would be 5x plus 3, and then x plus 2. And then this last one would be a 1, a 3x, another x, and a 5. You guys can put this together, 3x plus 1, x plus 5. And then this one over here would be a 5, 3x again, another x that you pull out, and this would be a 7. So 7 times 3 is 21, and that'd be 35. So there's your answer right there. I'm not going to put in brackets. You guys can do that going forward. All right, now we're going to change it up. If you need to know what those answers were, pause the video, back it up, and do it again. Now it's the same setup, right? Identify the A, B, and C. Okay, it's very important as you move forward. So that way you guys kind of develop the pattern that exists amongst the A, B, and the C, okay? So when you have a pattern, the biggest thing that you guys will be able to tell in math is that there's always sometimes a pattern of how things are done. And in this instance, we know here, okay, that if we have negatives at the end and a positive number here, that one of these numbers is going to have to be positive and one's going to have to be negative, right? So we know our A here is 5, 12, and negative 9. So let's just go right away and go in here. So it's A times C on top, which is negative 45, and then the bottom would be 12. All right, now remember what we talked about. One of these has to be addition, one of these has to be subtraction, due to the fact that this is a negative number up here. All right, this is positive, so we're looking for a bigger number. And if you don't know your times tables, go ahead and you guys would want to fill out and try to make sure you understand what they are. I have a cheat sheet over there where I've already done the work. It'd be 15 and negative 3. So 15 minus 3 is 12, and then 15 times negative 3 is negative 45. All right, A value is 6, 3, and negative 30. Bigger number here. This is negative 90, right? Or no, negative 180. 90, that's funny. And then this is a 3. This is a huge number. A lot of you may not understand and get this. So what you got to do is use your calculator. Start dividing out 180, and you know you're going to have something close. It actually comes out to be 15 and negative 12, okay? If you were to do your functionality like that. And then this one right here, ladies and gentlemen, is a negative 18. And then there is an 18 and a negative 1 and a 17. All right, here's one thing I forgot. One thing that we have to discuss here, this one is actually incorrect. It is correct, but it's not, because we have a problem here. One thing that I forgot to mention, and I was going to bring up earlier, but I did forget, was the fact that on this whole problem, ladies and gentlemen, one of the things you have to look for, which I forgot the rules of, is a greatest common factor. All right, so what I mean by that is if looking at this, there's 5, 12, and 9. Do these numbers share anything in common? The answer is actually what? No, they don't. 3, 17, and 6, do they share anything in common? The answer is no. Okay, 6, 3, and 30, do they share anything in common? The actual answer to this is yes, they do. You can take out or factor out, like we've done in the past, a 3 from every single piece here. So if I factor out a 3 from here, what would left behind would be 2x squared. Then this would be plus x, right? Because if I factor out a 3, and then this would be minus 10. How do I know? Go backwards, right? So 3 times 2 is 6. That'd be 3. That'd be 30. Now we need to do this values. So hopefully when you guys are doing this, that you're actually doing this not just in pencil, because I don't want to make a mistake, and if I do, then I want to make sure we go back and change it. All right, so my values are 2, 1, and negative 10. All right, so now what we have to do from here is do your setup. So the top value is going to be negative 20, and this is going to be 1. And then what two values would that be? That would actually be 5 minus 4, right? 5 minus 4 is 1. Multiply them together, you get negative 20. All right, now we can do our Punnett Square. This is 5x squared and 12x. And then, whoops, not 12x, sorry. And then 15x and negative 3x. And then the last term is negative 9. So now we want to use the new setup here. First term is 2x squared. The last term is negative 10. And then between, I have a 5x and a negative 4x. And then over here, I've got a 3x squared and a negative 6. And my two terms are 18x and a negative x, just like that. Now, one of the things you guys got to understand when it comes time to do these things is what is your greatest common factor when you pull it out again. This is a negative 3. This would be a 5x. This would be an x. And then this would be a 3. Okay, so there's my numbers. I don't have to do anything else. This one right here is a negative 2. This would be just an x. This would be a 2x up here. And then vertically speaking would be a 5. Now the trick with this one, and there was actually an example like this if you guys did your homework, on the part 1, I put in a question that was similar to this, where you had to factor first, and then you could get the answer. Okay, so technically speaking, this is the answer. If you try to do the Punnett Square without factoring it, you wouldn't be able to actually do it because the number would be so large. Try it if you want. Okay, try to figure out what the numbers would be, factor it out, and see if you can work. The problem is that it actually won't. All right, -1 here. This is a 3x. This would just be an x, and then up here would be a 6. So if I multiply this out, we'll all get the same. So it'll be 3x minus 1, x plus 6. All right, make sure, ladies and gentlemen, that you cannot factor anything out of any of these on a guided practice before you solve them. All right, hopefully you guys look through this process. I'm going to go left to right on this one. 8, 2, and 3, they don't share anything in common, so I write it down. 2, 19, and -10, they don't share anything in common, so I'd write those down. This one, however, 6, 22, and 8 actually do. They are all even numbers, which means you can factor out a 2. Okay, so I would want to rewrite this with a 2 pulled out. All right, so this would be 3x squared plus 11x, and then it would be minus 4, right? That's a 2 factored out. So my values here would be 3, 11, and -4. So now, when you fill in the gaps, on this, hopefully you guys see the setup and the process here, where this would be a -12 on top and 11 on the bottom. This would be a 19 and a -20. And then this would be a 2 down here and a -16 on top. Let me make sure of my notes. And yay, not -16, -24, because of course I can't do multiplication. That's what happens when you have a long day. Now, what two numbers would you multiply together to make -12, but when you add, make a positive 11? That, of course, would be the number 12 minus 1. So remember, one of these has to be negative here. And this one here would be the same style of setup. It would be 20 minus 1. So that way you guys know you get a positive 19. And this one over here, ladies and gentlemen, would be a 6, -4. All right, so now you fill in the squares. This is the first term. That's the last term. 6x and -4x. All right, first term, 2w squared, -10. And then the middle two terms here, so it'd be 20w and whoops, almost put -x, -w. And then here, ladies and gentlemen, this would be do the setup with the 2 functionality here. So this would be a 3x squared goes in here, and a -4 goes down there. And then you have to make sure you put not a 3, a 12x and a -x once again. All right, now let's solve these. Pretty simple, straightforward, right? 3x, and then this is -1, and then this would be x on top, and this would be a 4. So make sure you guys include the 2 in the front, like it has up there, 2, and then it would be 3x minus 1, x plus 4. All right, so that's how you would write that one out. This one here, they share a -1, then they share a 2w, then they share a w, and a 10w there. Oh, not 10w, oops, just a 10. Can't go too fast. Write those out, you'd be fine. This one here, same thing, -1. This would be a 2x. Now we have the first time ever where we're actually splitting the variable, which is why the Punnett Square method works really good for this. So it's 4x. This, when you do another method, sometimes you'll have, it's a little difficult to try to get the two numbers, but when you have a Punnett Square and you can do something like this, this makes this exercise so much easier. Okay, and I can't stress enough how when you do the Punnett Square correctly, it actually makes it so that you get two binomials that are perfect that would take forever to try to figure that out previously. So hopefully you guys understand the process, okay? All right, we have a couple more examples. Now we're going to be talking about, once again, we have done this in the past, where it's going to be if A is positive and B is negative, then ladies and gentlemen, remember this is going to be two negatives that we're looking for, okay? So A, B, and C. All right, it's 2, -15, and 18. And we know our two values here, we're going to have, both of them are going to be negative, right? So when you fill this in, it's -15. And then this would be 6 and 1 would be 26, I think. No, 36. Come on, Jason, figure it out. 36. Woo! All right, 36. What two values would come up with that? It would be 12 and 3. So now you would do your Punnett Square. First term, last term, and then the terms in the middle. And then you can factor this out. So if I factor these all out, that's a 3, that's a 2x, that's just an x. And then, ladies and gentlemen, this would be a 6, and bam, we're done. All right, next, move on. A, B, C. All right, it's 3, negative 17, and 20. And let me stop and look and make sure there's nothing I can factor out. Nope, that's odd, odd, even, even, odd. Nope, can't do it. Okay, good. I almost thought I was going to mess up again. All right, so now what you want to do on here, same setup, is A times C goes on the top. That would be 60. Negative 17 goes down here. And then what two terms would multiply to make this? This would be negative 12 and negative 5. Multiply those together, you get positive 60. Add them together, you get a negative 17. We worked on this yesterday on our little worksheet that we had in class. Hopefully you guys understood why I did that, so that you can be successful doing this. And then a positive 20. Right? It's very important to me that you guys are successful in when you are doing the work. I'm not just assigning you the work to try to make sure you guys can do it. I'm making sure you can, I'm assigning you the work to make sure that you're going to be successful as we keep building up. Okay? I don't want to leave anybody behind and trying to struggle to figure out exactly what you're doing. All right, any questions on this? Let me make sure as I'm talking, yes, yes. Once again though, what are we running into on this one? It's the same problem we ran on this one here, which I forgot to do over here. This is not the answer because this is a, where are the negatives? It's got to be that. Where are the negatives? It's got to be that. It's not there, so there's it. So now double check. So that's the actual answer. And then the last piece here, as you're going forward, make sure that you have it. It would be A, B, C. 24, negative 22, and 3. And then you do your setup here. And my numbers come out to be 72 and negative 22. Okay, and then you have your setup. When you do your equations on the inside, ladies and gentlemen, you would get the following numbers of negative 18 times negative 4 is 72. When you add them together, it's negative 22. All right, same now on the setup. Okay, make sure you do the Punnett Square. This is one of those things where I talked about in class, but I forgot to mention here. When you're factoring these out, this is like that special cases with the added inverse that we had covered in class. Some of you, when we did that, you kind of spaced it out. And now hopefully you guys understand. And what I mean by that is when we factor this, this is just a 1, right? When we factor this one out here, this is going to be a 6a. When we factor this one out, it's actually a 4a. And then when we factor this one out here, this is actually ends up being a 3, right? But when we do all the factoring, we're missing the negatives. So what you guys have to do is make sure you understand that you plug in the negatives at the end, right? So this one ends up being 6a minus 1, and then 4a minus 3. That's a thing of beauty. Your turn. Ladies and gentlemen, make sure you can't factor anything out first, and then try to solve. All right, now, ladies and gentlemen, same setup, right? 4, negative 13, and 10. Okay, and this would be 3, negative 37, and 44. And then the final piece would be 14, negative 15, and 4. Now you put the pieces together and do your multiplication. So, trying to find my place on here. So, this one here is 56 and negative 15. And then what two numbers would that be on the inside? It would actually be negative 8 and negative 7. And then you move on over here. Let me just grab this so I have it. This would be 132 and then negative 37. And then you have to do your tables to figure things out. It actually comes out to be negative 33 and 4. That's a big, bad, nasty looking one. And then a more simpler one, 40 and negative 13. And this one comes out to be negative 8 and negative 5. Okay, so hopefully you guys came out and you figured these problems out without my assistance. If you did not, please just double check your work and make sure you guys can do these. Once again, like I say, it's very important that you guys push through the process, okay? And don't give up. All right, so this one here is 4n. As you factor it out, this would be an n, and that would end up being a 2, but it needs to be a negative and a negative there. This one right here is 3x squared, negative 33x, negative 4x, and 44. So I factor out a 4. I factor out a 3x here. Then I factor out an x here and an 11 here. But this one and that one have to be negative due to the signs on the inside. And negative is a positive. So that's how the Punnett Square will help you guys. Believe me, in the past, this was always a struggle for a lot of my students. And I hope using the Punnett Square is actually going to help alleviate that problem. Okay, so it ends up being, this is negative 1. This is going to be a 2y. That would be a 7y. And then the last piece here is a negative 4. If you have any questions, make sure you see me in class. Okay. All right, a couple more. Now we wanted to work on the very last kind where it's a negative and negative. I wanted to make sure as I threw the negative and the negative in so you guys could do the same thing. All right, so now I'm going to skip a step. I'm not going to label the A, B, and the C. Please go ahead and feel free to keep doing that if you need to. But I don't want this video to be any longer than what it already is going to be. All right, so I'm just going to plug in the values of what these terms are, and then we'll go from there, right? So this first one here, this is negative 18 and negative 3. This is negative 21 and negative 4. And this one here would be negative 60 and negative 11. Now, same thing applies. If this is both negative, then one of these numbers has to be positive, the other one has to be negative, but it's going to have to be the bigger one over here. So this is actually ends up being 3 minus 6. So you subtract, you get negative 3, you add it together, you get 18. This would be 3 and negative 7. And then this one over here would be 4 and negative 15. All right, now you put your pieces together as you go through this process, right? So Punnett squared, 2n squared. Then it would be 3n. Then it would be negative 6n. And then it would be negative 9. This one here, 3x squared and negative 7. And then 3x and negative 7x. And this one here would be 6y squared and negative 10. And then it would be 4y and negative 15y. Woo! Fast and furious. Factor it out. Negative 3n, 2n, and a 3. Make sure everything multiplies and lines up. And it does, so you don't have to do any weird signs like you did before. Negative 7. This would be a 3x on this side. Vertically, that's just an x. And vertically, that would just be a 1. That'd be a 1, that'd be a 3, that'd be a 3x squared, negative 7. Perfect, we're done. This would be negative 5. This one ends up being a 2y. So the top would be a 3y. And then the back side here would be a 2. Make sure you multiply it up. 6y squared, 4y, negative 15, negative 10. We're done. Your turn. All right, now on the same setup, guys, I'm not going to do the ABC, but what I am going to do is make sure you guys can do the factoring. This is going to be, ends up being negative 12 and negative 11. This is negative 10 and negative 9. This ends up being negative 18 and negative 17. Now, what I didn't realize when I was doing these notes was that when I did this, I chose all of these to actually be a similar style where they're all set up like this. I didn't realize it was all going to be 1, 1, 1, and 1, but lesson learned. So now on here, it'd be 6b squared. This would be just a b, negative 12b, and a negative 2. 5r squared, and then just r, and then just negative 10r and negative 2. 3x squared and negative 6, and then just be an x and negative 18x. And now you can do the factoring with it. So the factoring here on this side would be negative 2b, 6b, and a 1. Check the answer on that, you'd be fine. Going left to right would be negative 2. It'd be not 5. Whoops. negative 2r, and then this would be 5r here, and then that would be a 1, negative 6x, 3x, and a 1 there. They all end up being down the same. If you have any questions, come see me. Last thing, determine whether something is prime or not, okay? This is one of the more difficult ones. I wanted to put these in here because there will be, maybe sometimes you guys will run into this problem where we can solve this using the quadratic formula, maybe not. And what it is it's a prime number where when you factor these out, you can't actually get the answer, okay? So what I mean by that is that the number and the variable, so this would be 2, negative 7, and 7. We do our equation here, our little x, the number we would get up here would be 14 and negative 7, right? The question is there any number that you can multiply to make 14 when you add to make negative 7? Well, there are two answers, 1 and 14 and 2 and 7, and that's it. Neither one of those come out to be negative 7. So ladies and gentlemen, you cannot factor anything on this one. This in fact is prime, okay? Now, do the next one real quick. If you go through this process, A, B, and C, okay? So the A value on this one is 6, negative 2, and negative 8. One thing I noticed right away is what can you do on this? You can actually factor out a 2. All right, so let's back up the train just a touch. Let's factor the 2 out first. So if I factor out a 2, I get 3x squared minus x, and then it'd be minus 4, right? Now let's change the values here. 3, negative 1, and negative 4, right? So let's see if we can factor this out. Now my b is negative 1, my c would be negative 12. What two numbers, when they multiply together, make negative 12? So we would have to think of our multiplications. We got 1, 12, 2, 6, 3, and 4. If I subtract 3 and 4, can I get negative 1? I can, if it's negative 4 and 3. So I can factor this one. All right, so I want you to factor it out. So not 6. This ends up being 3x squared minus 4. And then this would be a negative 4x and a 3x here. And then when you figure out the factoring part, this would just be a 1, be an x, vertically would be the 3x and the minus 4. Check your answer to make sure it works and it's legitimate, and it is. So my final answer for this one would actually end up being 2. And then you would go 3x minus 4, and then x plus 1. That would actually be the answer. The other one over here is making sure you guys can do it on this one. So it's 3a, 7, and 5, right? So same thing. A is 3, B is 7, C is 5, okay? So when you multiply this out, it's A times C is 15. Once again, I have a 7 on the bottom. So what two numbers would multiply to make 15? And when you add them, because this is all addition, make 7. Well, the only solutions are 1 and 15 and 3 and 5. And 3 plus 5 is not 7. It is 8. So this also is prime. All right, ladies and gentlemen. Hopefully you guys understand that. There are times where you're not going to be able to factor it. Now, the only reason I hate showing prime is because if you guys can't figure out the math, you'll say everything is prime. The likelihood of that happening on a test is slim to none. Last one, you guys do it on your own, please. All right, last setup, guys. Make sure when you're going through this that you can actually figure these prime numbers out and see if you can do it or not. All right, so this is going to be 21, 8, and negative 4. And this is an odd number. You can't pull a 3 out, so I know you can't factor.